In this video, we're going to learn about prime and composite numbers. A prime number is a whole number greater than 1 whose factor pairs are only the number itself and 1. So some examples: the smallest prime numbers are 2, 3, 5, 7, 11, 13, 17, 19. There is no end to this list of prime numbers. There are infinitely many. A composite number is a whole number greater than 1 which has at least one factor other than itself and 1. So some composite numbers are 4, 9, 12, 51, 91. This is divisible by 2, by 3, 2, 3, 4, 6, lots of numbers. These may look like you can't think of any factors right away, but they actually do have factors besides one in themselves. 51 is divisible by 3, 91 is divisible by 7. So we're going to have to be careful when we're trying to determine whether a number is prime or not. So that's our goal. We are going to determine whether a number less than 121 is prime or composite. Okay, and we're going to use the following fact. A number less than 121 is prime if it is not divisible by 2, 3, 5, or 7. Okay, so if we were checking larger numbers, we'd have to check more prime factors. But for these smaller numbers, we're going to use the following method. We're going to be given a number less than 121. We will check to see if it's divisible by 2, 3, 5, or 7. And if it is divisible by any of these numbers, then we know it's composite and we're done. If we check all of them and it's not divisible by any of these 4 numbers, then we can say the number is prime. Again, for any number less than 121. So let's look at some examples. So we have the number 105. Okay, we need to check 2, 3, 5, and 7. There's actually some nice shortcuts for 2 and 5, which you may be aware of. 7, there's tricks, but they're a little bit tricky. And there's a shortcut for 3 I'm going to show you as well. Okay, so 105, okay, ends in 5, so I know it's divisible by 5. So a number that ends in either 0 or 5, we could say is divisible by 5, or another way to say that, or has 5 as a factor. And if a number has a factor besides 1 in itself, it's not prime. So for 105, we can say this ends in 5. Okay. Now we were also asked it to show at least one factor pair. So let's divide 105 by 5. And we get 21. Okay. So 5 times 21. So we can now say 105 is composite. It actually has other factors. I could see it's divisible by 3 and 7, but if you're trying to find whether it's composite or prime, if you find one factor besides 1 in itself, you're done. Okay, now we have 71. Okay, well, here we had a test for 5. There's also a nice test for 2. A number that is divisible by 2 is even, which means it ends in 0, 2, 4, 6, or 8. So you may remember finding multiples of 2 when you were younger. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I can still do that well. Or multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40. Okay, so we can use these ideas so it's easier to check 2 and 5 if a number is divisible by those. So 71 is not even. So 2 is not a factor. Okay. For 3, again, there's a trick for 3 that you could look up, but if you're interested, but I'm going to just divide by 3. There's a remainder, so it is 3 is not a factor of 71. Okay. For 5, it does not end in 0 or 5, so 5 is not a factor. Okay. So notice we checked 2 of them very easily. 3 we divided, and for 7 we're going to divide. So if I divide 71 by 7, there's a remainder, so now 7 is not a factor of 71. So now that we've tested whether it's divisible by 2, 3, 5, and 7, and it is not, that means that 71 is a prime number. Let's check 119. So, ends in 9. So it's 2 is not a factor. Okay. Also notice 119 is less than 121 because these 4 numbers only work for numbers less than 121. Let's check 3. So 119 divided by 3. There's a decimal, which means there's a remainder, and that means 3 is not a factor. Since it ends in 9, it's not ending in 0 or 5, so that means 5 is not a factor of 119. So we have one last number to check, 7. And look, it goes in. So we have 7 times 17 equals 119. So we did find a factor besides 1 and 119, which means 119 is composite. Okay, and I want you to notice that when you look at 119, you can't think of any factors off the top of your head. I thought this was the case, but I wasn't even sure, because our multiplication tables don't go out to 17, so you probably aren't familiar with this multiplication fact. Okay, so it's tempting to look at numbers, and if they end in 1 or 9 or 3 or 7, to just think, oh, I can't think of any factors, it must be prime. Okay, but you really need to go through this process and check all of them to be sure, since you don't know all the factor pairs that could possibly multiply to the number.